Welcome back, everyone. In this video, we're looking at one more example on binomial random variable. And this one says, suppose we inspect a sequence of items from a production process. So it's an inspection process when products are produced. And each item is classified as either conforming or non-conforming. Note that proportion of items that are not conforming is 3%, right? So here, success or quote-unquote success is when a product is non-conforming, and probability of success is 3%. And that's based on historical data that maybe this producer collected from past production batches. Part 1 says, on average, how many of the first 100 items inspected will be non-conforming? So the key word here is, it says on average. And on average tells us that we're looking for expected value. We're looking for expected value of a random variable. What is the random variable? It says first 100 items. So that means the random variable is n100. And we want to know what is the expected value of n100, which means how many items are we expecting to be non-conforming in the first 100 trials. That is equal to n times p, so 100 times 3%, 3 items. Part B, what is the probability that 2 of the first 100 items inspected will be non-conforming? So probability of 2 successes out of 100 trials. We're calculating probability of n100 equals to 2. That is 100 choose 2, 0.03 to 2, 0.97 to 98. Some of you might have calculators that allows you to calculate coefficient of binomial with the calculator instead of going through the formula by hand. But in any case, calculating that coefficient is not that difficult. Here we have 100 factorial divided by 2 factorial times 98 factorial. And make sure that when you have numbers large as that, don't put in 100 factorial in the calculator and try to divide it by 98 factorial. Simplify that by canceling these first, and then at the top you would left with 99 times 100, right? And just divide 9900 by 2, and that's what you're looking for. So that's the coefficient of binomial times 0.03 squared times 0.97 to 98. And when you do the math, you get 0.23, 23% chance. What is the probability that at least 2 of the first 100 items inspected will be non-conforming? Well, when it says at least, means 2 non-conforming, or 3, or 4, or 5, and it goes all the way to 100. And that's a lot of probabilities to calculate, right? We're looking for probability of n100 greater than equal to 2. And that means n100 equals to 2 plus n100 equals to 3, all the way to probability of n100 equals to 100. That's a lot of probabilities to calculate. What's the smart way of approaching this? The better way to approach this is to calculate the complement of this probability and deduct it from 1. That is equal to 1 minus probability of n100 less than 2, which means 1 minus probability of n100 equals to 1 minus n100 equals to 0. Now, you just need to calculate these two probabilities. And when you do that, you should be getting 0.805. Now, this problem gets more interesting here. It says, if two of the first 75 items inspected are non-conforming, then calculate these two parts. So you have this given part again. And the given part is essentially saying that N75 is equal to 2. We got 2 successes in the first 75 trials. Now, given that, what is the probability that 5 of the first 200 items inspected will be non-conforming? Well, we're calculating probability of N200 equals to 5, given that N75 is equal to 2. That means we have passed through the first 75 inspections and we got 2 successes. What's the probability of 5 successes in the first 200? Well, keep that in mind that this 75 is inside this 200. It's the first 75 of that. So after the 75 inspections, you're left with 125 more inspections, and you're looking for 3 more successes. So you can calculate that. 125 choose 3 times 0.03, probability of success to 3 times 0.97 to 122. I leave the math for you to calculate here. Part E says on average, again, on average indicates that we're looking for expected value. How many of the first 150 items inspected will be non-conforming? Again, that is given this fact here. So we are calculating expected value of N150 given that N75 is equal to 2. Well, if we already got 2 successes in 75, there are 75 more trials left. So we're essentially looking for expected value of N75. But you would have to add the 2 successes that you already got in the first 75. So that is N times P plus 2. That is 75 times 0.03 plus 2. That is 4.25 successes on average.